Today we are going to see the numericals of upthrust. Now before we start the numerical, let us revise some formulas. In this formula, we are going to first see weight in air. So weight in air is m into g, which can be written as v ds g. Okay, where v stand for volume of the body, ds stand for density of the solid, and g is acceleration due to gravity. Now when this body is immersed in a liquid, the upthrust that the body gets is v dlg, where this V is the volume of the body that is submerged inside the liquid. So if this is the liquid and we are talking about the body submerged to this part, then this V stand for only this. The V stand for only the part of the body that is inside the liquid. Okay. Now when the body is submerged inside and it gets an upthrust which is greater than the weight in air, okay, greater than or equal to, then the body will float. But if the upthrust is less than the weight in air, the body will sink. Okay. Another point is weight inside liquid will be weight in air minus the upthrust. Okay. So with these formulas, we can start with the numericals. This is the first question. The following information is given. Volume of the body is 100 centimeter cube and weight in air is equal to 5 kilogram force. It is completely immersed in a liquid of density. So density of liquid is 1.8 into 10 to the power 3 kg per meter cube. So the first thing that we need to find is the upthrust, and the second what we need to find is weight of the body inside the liquid. Okay. So here this is centimeter cube, and rest all the information is given in SI. So just a revision. 1 centimeter is 10 to the power minus 2 meter. 1 centimeter squared is 10 to the power minus 4 meter squared. 1 centimeter cube is 10 to the power minus 6 meter cube. So therefore, the volume, which is 100 centimeter cube, will be 100 into 10 to the power minus 6 meter cube. Now 100 is 10 to the power 2, so this will be 10 to the power minus 4 meter cube. Okay. Upthrust is VDLG, so that is 10 to the power minus 4. This is 1.8 into 10 to the power 3 into G. So 10 to the power minus 4 and 10 to the power 3 will give you 10 to the power minus 1. That is 0.18 into G. So the upthrust will be 0.18 kgm. Remember, upthrust is also a force. So the unit of upthrust will be Newton or gram force or kilogram force. Then the next thing that we want is weight inside liquid. That will be weight in air minus the upthrust. So that will be 5 minus 0.1882 kgm. So weight inside liquid is 4.82 kgm. This was the first question. Now we go to the second question. Okay, so in the second question, the information that is provided is weight in air is 450 gram force. Weight in water is equal to 310 gram force. Following information is required. Volume. The weight in water will be weight in air minus upthrust. So therefore, 310 will be 450 minus upthrust. So we get the upthrust is 450 minus 310. And therefore the upthrust is 140 gram force. Okay. Now upthrust is also the loss in weight of the body, because if you see, if this body was suspended in air, this reads 450 gram force. And when the body is suspended in water, it reads 310 gram force. That means how much has the body lost its weight? It has lost 140 gram force. Okay. Loss in weight is 140 gram force. Now the third part is the volume of the body. So the buoyant force of thrust is volume of the body, density of liquid into gravity. So this is 140 gram force, that is V into 1 into G. Now why 1? Because this is water and density of water is 1 gram per centimeter cube. So therefore we get V as 140 centimeter cube. So we got the third thing that they have asked, that is the volume of the body. Let us go to question number 3. Okay, so in this question, what is the information that we have? There are two spheres given to us. So one is a hollow iron ball, and that is labeled as A. There is a solid iron ball. So the following information that we have for them: mass, volume, and density. So here it says that the hollow iron ball has a volume of 15 centimeter cube and the mass is 12 grams. So this is 12 grams. And the solid iron ball also has mass of 12 grams. And it is given that the density of iron is 8 grams per centimeter cube. So we don't have the volume, and here we don't have the density of the hollow iron ball. Okay, so we know that density is mass upon volume, and therefore this is 12 and this is 15. So this is 3 fours are 3 fives are, that will be 0.8. So over here density is 0.8 grams per centimeter cube, which is less than water, so therefore it will flow. Okay, the second thing that they have asked is the volume of the solid iron ball. So here again density is mass upon volume, volume is mass upon density. So mass is 12 and density is 8. So 4 twos are 4 threes are. So that will be 1.5 centimeter cube. So this is 1.5 centimeter cube. Now that we have calculated these things, let us answer the question. So the first is upthrust on each ball. So here we know that upthrust is VDLG. So volume of ball A is 15. Okay. So this is 15 into 1 into G, and that will be 15 gram force. Okay, now over here, the weight in air of this ball is 12 gram force, and this is also 12 gram force. Now, since this is greater than the weight in air, that is 12 gram force, therefore, the upthrust that this ball receives will be only 12 gram force. The meaning is that if you take this as air and this is water, when this sphere is completely immersed inside, then it is going to get an upthrust of 15 gram force. But the fact is that this sphere has a weight of 12 gram force acting downward. So therefore, this sphere is not going to completely sink inside. This sphere will float with a part of it above water, so that it gets an upthrust equal to 12 gram force when its weight is also 12 gram force. Okay, so sphere B, when it is completely immersed, will get an upthrust of 15 gram force. But since 15 gram force is greater than its weight in air, it is going to get an upthrust of 12 gram force, which is equal to the weight in air. Okay, then therefore we can say that A will float. Okay, what about the sphere B? Again, VDLG. So volume is 1.5 into 1 into G. So that is 1.5 gram force. That will be the upthrust that sphere B will receive. Now, since 1.5 is less than 12, okay, because 12 gram force is the weight, therefore B will sink. Okay, the sphere B, even when it is completely immersed inside, will not get an upthrust that balances its weight, therefore it will sink. Okay, so this is the answer to that question. Let's move to the next.